In 7.3, we're going to spend time learning how to find a least common denominator. And a least common denominator of two or more rational expressions is just the least common multiple of the denominators. So what I do, I want to write the prime factors of each of the denominators. So 36 is 6 times 6, but 6 and 6 are not prime. 6 is 3 times 2, and 3 times 2. So 36 can be written as 2 squared times 3 squared. And that's because the multiplicity of 2, it happened twice, and 3 happened twice, okay? So looking at 24 is 2 times 12, which is 2 times 6, which is 2 times 3. And now we have prime numbers. So instead of writing 24 right here, I could think of that as, let's see how many 2's there are. There are 3 2's, so that can be written as 2 cubed and 3 to the first power. So when you're building the LCD, you want to look at what bases you have in common, and you want to cover those, write the highest power of that, and then anything that's left over. So we have a base of 2, we have a base of 3. In common, there's nothing left over. And so now I just want to choose my highest power of 2. Well, my highest power of 2 was 3. And my highest power of 3, I have a 3 to the first and a 3 squared. So the highest power of 3 that I see is 2. So 2 cubed is 8. 3 squared is 9. And 8 times 9 is 72. So last time you can see that I wrote the factors factored out in denominators. You don't have to do it like that. I mean, I'm going to just write them out, with an equal sign this time. So 3 is completely factored because it is prime. And I'm going to just write s squared as s squared and t as t. It really didn't change, okay? 6, however, is 2 times 3. And then you have a factor of s, and then you have a factor of t to the fourth. So when building that LCD, let's back up and read the definition or read how to do it. Step 1, factor all denominators completely. I did that, okay? We factored 3 and 6, and it's factored completely. So when building the LCD, I want to write the product of all the unique prime factors in the denominator. So unique means all the different bases that we see, okay? And we want to raise each factor to the highest power that it appears in any denominator. So that means the unique factors, well, we see a 2, and there's a 3 right here, and an S, and a T. And that covers all of the different numbers. 2, 3, there's that S, T, there's all the numbers and variables. So now we want to assign each of those factors the highest power in which we see it. So 2 and 3, well, 2 is just to the first, 3 is to the first, so those stay the same. The highest power of s that we see is s squared. The highest power of t that we see is t to the fourth. So here is our LCD. So number 3 is a lot of fun. 4 over y squared minus 9. So step 1 is to write the denominators in factored form, completely factored. You can see that I am writing this in the denominator this time instead of multiplying it out to the side like I did in the last problem. Factors of 9 that add to give you -6, y minus 3, and y minus 3. So, LCD, what are the different factors that you see? Okay, we see a y plus 3, so let's write it down. We see a y minus 3. And we see a y minus 3 and a y minus 3, and I've already got that written down. Okay, so now you want to give these factors the highest power. You want to raise it to the highest power in which it appears in any denominator. Well, this on the left, this y plus 3 was to the first, and this y minus 3 was to the first. Okay, on the right side, the y minus 3, you might as well have written that, it happened twice, right? So we might as well have written that as y minus 3 squared. So that means in the LCD, that factor of y minus 3 needs to be squared as well. When we are looking at number 4, d minus 6 and 6 minus d, if you'll notice, they're opposites. You could factor a -1 out from one of them, and the inside that you would be left with is, going to be the same as the other. They're exact opposites. The d is positive here, it's negative there. The 6 is negative here, the 6 is positive here. So that means your LCD basically could be either one. It could be d minus 6 or 6 minus d, again, because they're opposites. In problems 5 through 10, we're going to still continue to find LCD, but it wants us to go one step further and convert each expression to an equivalent expression with the denominator equal to the LCD. So basically, once we find the LCD, rewrite each fraction so that it has a denominator of that LCD. So 6, we can think of that as 2 times 3, and then we still have x cubed and y squared, and 15 is 3 times 5, and you got y cubed. So the LCD would have a factor of 2 and a factor of 3, a factor of x and a factor of y, and, it's also got a factor of 5. So all the different factors that we see, the ones that are in common and the ones that, anything extra as well. So now we want to assign the variables, we want to assign everything, we want to give it the highest power in which it appears in each denominator. So we have a y squared that appears in the denominator to the left and a y cubed that appears in the denominator to the right. So the highest that I see is a cube, and x cubed is the highest power I see of that as well. And then the highest power of 2 and 3 and 5 that we have is 1. So our LCD is equal to 30x cubed y cubed. So now we're going to rewrite each expression so that it has a denominator of the LCD. So what I want to do, I want to think, what do I have to do to 6? What do I have to multiply it by to make it 30? Well, you can multiply it by 5. And do I need to multiply x cubed by anything to make it x cubed? No, you do not. Do I need to multiply y squared by anything to make it y cubed? Yes, you do. You need to multiply it by 5y. So what I'm saying is, if you multiply 6x cubed y squared by 5y, you would get 30x cubed y cubed. So whatever you do to the top, In order to make it an equivalent expression, you need to do, whatever you do to the bottom, you need to do to the top in order to make it an equivalent expression. So our answer would end up being 35y. And now we just need to do it for the 8x over 15y cubed. What do you need to do to 15 to make it 30? You need to multiply it by 2. What do you need to do to y cubed to make it y cubed? You don't need to do anything. But right now, if I just multiply 2 by 15y cubed, I wouldn't get 30x cubed y cubed. So you also need to multiply it by an x cubed. So let's try it out. 2 times 15 is 30. X cubed times y cubed is x cubed y cubed. So now I'm just going to do that to the top. And I get 16x to the 4th. So those are my 3 answers for this one problem: the LCD and the 2 equivalent expressions. Now number 6, looking at your 2 denominators, 3a plus 5, it doesn't factor. I mean, this is the factor itself right here. 3a plus 5 does not factor. A plus 5 does not factor. So for your LCD, you have a factor of 3a plus 5, and you have a factor of a plus 5. And they're both to the first power. So now that we have found that LCD, I want to rewrite both of those expressions so that they have a denominator that is the LCD. So I went ahead and put the new denominator in there. So now I need to think about, what do I need to do to 2 over 3a plus 5? What do I need to do to 3a plus 5 to make it, say, 3a plus 5 times a plus 5? Well, all you gotta do is multiply it by a plus 5. And what you do to the bottom, you must do to the top. So our equivalent expression is 2 times a plus 5 over 3a plus 5 times a plus 5. Now, what do I need to do to 4 over a plus 5? What do I need to do to a plus 5 to make it, say, 3 times a plus 5 times 3a plus 5 times a plus 5? Well, you could multiply it by 3a plus 5. And what you do to the bottom, you must do to the top. So basically, what was it missing, okay? And we get 4 times 3a plus 5. On number 7, we're going to factor our denominators first. And the b squared minus 10b plus 25 factors of a positive 25, so that multiply to give me 25 and that add to give me negative 10. We could use b minus 5 and b minus 5. Okay, and now b squared minus 25, that's a binomial. They're both squares. It's a difference of squares. And so that would be b plus 5 and b minus 5. I will say this, the b minus 5, notice that that is really, you could also think of that as b minus 5 squared. Now when we're building that LCD, you want to write down all of the different factors that you had. Well, we had a factor of b minus 5 and a factor of b plus 5. And that covers all of the factors that we have. B minus 5, B plus 5, and again, that's B minus 5. And now we want to go back and raise the factors to the highest power that we saw it in a denominator. Okay, so the highest power of b minus 5 right here is 1. The highest power of b plus 5 right there is 1. And so we're going to leave b plus 5, its power is going to be 1 because that's the highest it ever was. But if you look at b minus 5 over here, it happened twice. So its highest power is 2. So LCD is b minus 5 squared times b plus 5. So now we want to take that LCD and we want to rewrite both of those expressions so that its denominator is the LCD. So b squared minus 10b plus 25. What do I need to do to that? What do I need to multiply that by to make it equal b minus 5 squared times b plus 5? It may actually help if we rewrite b squared minus 10b plus 25 as its factored form, which we already know is going to be that b minus 5 squared that we found earlier. So now how do I make b minus 5 squared? How do I make this denominator equal this? Well, it's missing a b plus 5. So multiply it by b plus 5, and what you do to the bottom, you must do to the top. So 9 times b plus 5 over b minus 5 squared times b plus 5 would be that equivalent fraction. I'm going to go ahead right here. I'm going to erase the b squared minus 25, and I'm going to replace it with its factored form, the difference of squares. So b plus 5 times b minus 5. How do I make that equal to b minus 5 squared times b plus 5? It's pretty similar. The only difference is that this b minus 5 right here is squared, and this one is not. So how could I make this denominator have, instead of just a b minus 5, how could I make it have a b minus 5 squared? You can multiply it by another factor of b minus 5. And what you do to the bottom, you do to the top. So here is our equivalent expression. On number 8, we're looking at these denominators. We're wanting to factor them. 24h minus 18. You can factor out a 6. If you take a 6 out, 24 divided by 6 is 4h, and 18 divided by 6 is 3. And instead of writing 6 right here, I think it would be better to write 2 times 3, because that's our prime form of 6. On the next one, 16h minus 12. You can take a 4 out. If you take a 4 out, you would be left with 4h minus 3. And again, remember 16 is, 4 that we took out is 2 times 2. So the LCD, our factors are a 2, a 3, and 4h minus 3. And over here, our power of 2 is 1, our power of 3 is 1, our power of this is 4h minus 3 is 1. Right here, the power of 2, though, it happens twice, so 2 squared. To make our LCD 12, because 2 squared is 4, and 4 times 3 is 12. 4h minus 3. So for our equivalent fractions, these denominators, I just wrote the factored forms. And we're wanting to make each expression, we're going to want to make an equivalent expression that has the denominator using the LCD. So how can I make 2 times 3 times 4h minus 3 equal 12 times 4h minus 3? Well, 2 times 3 is 6, so that's basically saying 6 times 4h minus 3, and we have 12 times 4h minus 3. So all you need to do is multiply it by 2, and what you do to the bottom, you must do to the top. So let's double check that. 2 times 2 is 4, 4 times 3 is 12. 12, okay, so that works. And now the top just becomes 14. Okay, and in the bottom, on the bottom expression rather, you have 2 times 2, so 4 times 4h minus 3. What can we multiply 4 by to get 12? We can multiply it by 3. So that becomes 15h. So I want to factor these denominators. Factors of -3 that add to give you 2 would be w plus 3 and w minus 1. They multiply to give you that -3. They would add together to give you that -2. On the w squared minus 9, that's a different square, so we can factor that into w plus 3 and w minus 3. Just a plus and a minus, and we took the square root of the w squared and the square root of 9. And now we have another trinomial factors of a +3, what multiplies to give us a +3 but adds to give us a -4. If you're multiplying to get a positive number, the signs have to be the same. And since you're adding those same signs together to get a -4, they both have to be negative. So let's see, w minus 3 and w minus 1. If we multiply -3 and -1 together, we get that +3 that we're looking for. If we add them together, we get -4. So for the LCD, let's write down all the factors that we see. Okay, I see a w plus 3 and a w minus 1. Got that covered. Okay, now w plus 3, I've already written that down. W minus 3, I have not written that down. And you have a w minus 1 right here, but we've already written that down. So what's the highest power that occurs in each denominator? Well, here it's 1, so that would be 1. W plus 3 is 1 there, w minus 3 is 1 there, so they all occur only one time, a power of 1 in the denominator, so it stays as a power of 1. Now, had there been like another, w minus 3 right here, then we would say, okay, well then there's 2 in that denominator, so that the most time it appears in a single denominator is twice. But that wasn't the case. So now to make our equivalent expressions. So we had 3 expressions this time, and I wrote the denominators. I just wrote their factored forms. So now, how do I make this denominator, w plus 3, w minus 1, look like the denominator over here? Well, it's missing a w minus 3. So what you do to the bottom, you must do to the top, and we end up with 5 times w minus 3. Now this one, w plus 3 times w minus 3, w plus 3, w minus 1, w minus 3. So this one was missing a w minus 1. So multiply the top and bottom by w minus 1, and we end up with w times w minus 1. This one here, w minus 3, w minus 1, w minus 3, w minus 1. That one's missing a w plus 3. So 8 times w plus 3. Okay, for our last one, I just want to make sure everything's factored out. Over in the denominator of 3w minus 18, there's a GCF of 3. You would be left with w minus 6. And now the 6 minus w over here, that is the opposite of the w minus 6 that we see right there. So our LCD can be a factor of 6 and a factor of w minus 6, and we don't have to write down the 6 minus w, because again that's the opposite of w minus 6. So for our equivalent expressions, the 2 over w minus 18, 3w minus 18. See, it factored into 3 times w minus 6, which was our LCD. So we don't need to write an equivalent expression for that one. Its denominator is the LCD. The only thing I need to worry about is the 5 over the 6 minus w. And how would I make it have a denominator of 3 times w minus 6? Well, of course, I do need to multiply by 3 because it's missing a 3. But it also has to be a negative 3, because what that negative is going to do, the negative would change the inside of the 6 minus w. This negative is going to change this inside to be w minus 6. It'll make the 6 negative, and it'll make the w that was negative, it'll make it positive. So our answer would be negative 15 over 3 times w minus 6. And again, the 2 over 3w minus 18 already had that LCD as a denominator.